So the first one, I'm just going to call very simple trig functions. So what I mean by these types are, for example, ones like this. Let's say I said sine of x is equal to 1/2. And these are types that you could easily just look at the unit circle. That's why I put the circle here for us. And you would be able to tell where the answers are. So let me blow up our circle really quick. And hopefully you remember that on the circle, cosine comes first, sine comes second. So we are looking for places where this value is 1/2. So we're looking for coordinates that look like this. Who cares? Comma 1/2. And if you look at the circle, you should see one here. See how 1/2 is in the second value? So we definitely want pi over 6 as one of our answers. And you should see another one here at 5 pi over 6. So if I was solving this equation, I would, from the circle, very quickly be able to tell that x can be either pi over 6 or 5 pi over 6. Okay, I'll do one more example of a simple one. Well, I shouldn't call it that. Let me call it, here, I'll just put like star. So there are some where you might have to be a little bit fancy and solve. So for example, let's say I said this. Tangent x plus 1 is equal to 0, right? So you know that in order to look at the circle, you need tangent to be completely by itself. So if you were trying to get rid of this, if you were trying to get this alone, you would have to subtract 1. That would get rid of that, and then you would be left with tangent x is equal to minus 1. Now, here's the tricky thing about tangent. Remember that it's not immediately available to us on the circle, but if you remember the meme I showed you, hopefully you remember that another way to say tangent is sine over cosine. I showed you that Titanic boat meme in class before the distance learning, so that's going to be in handy. So pretty much we're saying the right, sine is on the right, divided by the left. Okay, so we're looking for when we divide the right by the left, where do we get minus 1? So let's see, that would not be. This almost is. If I do square root of 2 over square root of 2, I get 1, but I want negative 1. So not quite, not quite, not quite, not quite. Okay, so here's our first one. So if you look right here at these two, you will notice if I do right over left, that simplifies to minus 1. So one of the answer choices I want is 3 pi over 4. Another one, let me see, I should be able to get one more. Not there, not there. So this one, again, almost, except it's a negative divided by negative, so that would be positive 1. And then here, so if I went here, that would be negative radical 2 divided by radical 2, which is negative 1. So 3 pi over 4 and 7 pi over 4. Okay, so those are the kind that I mean by simple when I say simple. Okay, let me upgrade it a little bit to... So for number 2, we're looking at ones that involve reciprocal, right? So if you remember from class, the reciprocal ones are secant, cosecant, and cotangent, right? Because those are the ones that we flip. So for example, I could give you one like this. So I could say, what is cosecant x is equal to negative 2. Now in this case, let me bring the circle down with us. Oh, I almost sneezed. Okay, sorry about that. So Why is my circle not moving? Move circle. Okay. So for this one, notice that cosecant is not on the circle. Let me clean up our circle real quick. So cosecant is not on the circle, but if you remember who's related to who, let's do a quick review. So sine, cosine, and tangent. So let me give you a second to think, or just pause this real quick while you think. You should remember that sine is the reciprocal of cosecant, cosine is the reciprocal of secant, and tangent is the reciprocal of cotangent. So if I use that logic, right, I can transform cosecant x into sine x. But if I do that, I have to flip this fraction like that. And now I can look at the circle. So I'm looking for coordinates that look like something comma -1/2. So that would be down here at 11 pi over 6 and down here at 7 pi over 6. So those would be the two answers for you. Okay, and also notice that sometimes you get, let's see, sometimes you get ones like this. So here's another example. Square root of 3 secant x is equal to -2. And again, notice that this is pretty much almost the same thing, just you want secant to be alone. Once you get secant alone, you can solve it. So we're just going to do a quick division by radical 3. Division by radical 3. And notice that you get secant x is equal to -2 over radical 3. But if we use this relationship over here, we know secant, we want cosine. So flip it, we would get cosine x is equal to negative radical 3 over 2. So now we're looking for cosine values. So on the circle, that would be where does the coordinate look like that? And you should see, if I get rid of the ones that we just did, you should see, sorry, I deleted that radical. You should see one here and here, right? So then those two would be 5 pi over 6 and 7 pi over 6. Those would be your, oops, sorry, I have a big eraser. 5 pi over 6, 7 pi over 6. Okay. So we can keep going. You could also see ones that have squares, and I don't want you to be scared of squares, so let me do one with you. So let's say I had this. Let's say I had secant squared x is, secant squared x minus 1 is equal to 0. So again, your goal is to get secant alone, right? The secant x. So first thing would be get rid of this minus 1. So we're going to add 1. And if we add 1, that would be secant squared x equals 1. Now here's the thing. You don't want the square. This power of 2, you don't want. So if you remember from last semester, we had basic equations that look something like that, something squared. And we would get rid of this 2 by doing something called the square root. So whenever you see a power of 2, just think square root. Those will cancel each other. And also, when you take the square root, keep in mind that there are two answers. There's a plus version. Oh, wait, sorry. I wanted the pencil. There's a plus version and a minus version. Right, so that would be to the type that we would do last semester. Here, we're doing the same thing, square root, square root. So when you do that, keep in mind that you get secant x is equal to plus or minus 1. And again, we can't look at the circle immediately because secant x is not on the circle. But if we go back up here, we say secant is related to cosine. So we can say cosine x is equal to, well, here's the nice thing about plus or minus 1. If I flip that, it's the same thing, right? So either way you get plus or minus 1. And then if I go to the circle and I'm looking for plus or minus 1 in the cosine position, right? So I'm looking for coordinates that look like this or like that. So that would be right here, 1, 2. So then my answers would be 0, pi, and don't forget, even though this circle doesn't show it, this is 0, this is 0, and, why aren't you letting me write on it? This is 0, and it's also 2 pi, so don't forget that. So our x value can be 0, pi, or 2 pi, would all be answers. Okay. And then lastly, I would say the last kind that you might expect to see is what I would call ones where you have to combine like terms. Okay, so I'll do 2 examples like that with you. Here's a pretty good one. So one is like sine x is equal to 3 sine x minus 6. Okay, now notice that in this case, there's a sine x on both sides, right? But if you thought about it like this, right, let's say we thought about it like solving an equation from algebra, these two are the same family, so we can bring them together, right? So in this case, I would say, let's subtract 3x. Well, in this case, I would say, let's subtract 3 sine x, right? And then the number in front of here is 1. So those will cancel or undo each other. And then I just have to think, what is 1 minus 3? And in your head, hopefully you're saying minus 2 sine x equals negative 6. And then again, before you can look at the circle, you need to get this alone. So how would we get rid of that minus 2? Just do a quick division. And then you get sine of x is equal to 3. Okay, now here's the interesting thing. If we go to the circle, let me see if I can pull it down here. See if we can pull the circle down here. Okay, so there's the circle. Let me clean it up a bit. Okay, so the interesting thing about the circle is there a place where you see sine x equal to 3? And that means we're looking for a coordinate that looks like something comma 3. And nope, oops. Nope, 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 nope. So pretty much there's nowhere on the circle where that happens. So this would be no solution, which is possible, right? No solution. And then I'll do one more example with you. I'll do one that has tangent, so we can practice tangent. So let's say we had 9 tangent x plus 7 is equal to 5 tangent x plus 3. So again, in this case, we're going to combine like terms. So I see a 9 tangent and a 5 tangent. So let me subtract those. Right? Those will cancel, so this will be 4 tangent x plus 7 equals 3. The 7 and the 3 are also like terms, so I'm going to subtract 7. Now I get 4 tangent x is equal to minus 4. And if your goal is to just have tangent by itself, we can do a quick division by 4, and we get tangent x equals minus 1.